Alright, second lesson for the week is lesson 6, interpreting the standard deviation. So last lesson we talked about how to find the standard deviation. Now we're going to look at what does that mean, interpreting that standard deviation. Alright, so it says, your teacher will show you how to use a calculator to find the mean and standard deviation for the following sets of data. A set of 8 men have heights in inches as shown below. Indicate the mean and the standard deviation you obtained from your calculator to the nearest hundred. Well, guys, we aren't going to use any kind of special calculator. We're just going to look at how to do this. If we had our graphing calculators, we would be able to do it that way, but since we don't, it's okay. We are going to just do it the good old-fashioned way. So 67 plus 70.9 plus 67 and 6/10 plus 69 and 8/10 plus 69 and 7/10 plus 70 and 9/10 plus 68 and 7/10 plus 67 and 2/10. I'm going to divide that by 2, 4, 6, 8. Alright, and this is what I get. Alright, we're going to round it to the nearest hundredth. So to the nearest hundredth would be here. That's a 5, so I'm going to bump up. So I get 68 and 98 hundredths. Alright, and we are dealing with inches. Alright, to find our standard deviation, if you remember, we have to do the, we got to figure out, so we're going to use this and subtract this, alright? Then we have to square it, then we have to add it all together, divide by however many points minus 1. So instead of doing all that right now, no, I tell you what, we're going to do it all because we don't have the calculators quite to do it. So we're going to have to do these steps. Alright, so I'm going to have to, I'm going to subtract. So 67 minus 68 and 98 hundredths gives me a negative 1 and 98 hundredths. So 70.9, and guys, get your calculator out with me, and I want you to get used to doing this. So 70.9 minus 68.98 gives me 1.92. 67.6 minus 68.98 gives me negative 1.38. A light glaring on my calculator here. So that was this one. So 69.8 minus 68.98 would be 0.82. 69.7 minus 68.98 is 0 and 72 hundredths. 70.9 minus 68.98 would be 1.92. Alright, my paper's running out of the camera screen there. Alright, so 68.7 minus 68.98 would be a negative 28 hundredths. And 67.2 minus 68.98 would be a negative 1.78. Now you remember we got to square these, so I get 3.92. 3.69. 1.90, 0.67. And all I'm doing is squaring these. 0.52, 1.92 times 1.92, 3.69, 0.08, and 3.17. Okay. So now I add all of these together. 3.92 plus 3.69 plus 1.9 plus 0.67 plus 0.52 plus 3.69 plus 0.08 plus 3.17. So I get 17.64. And I'm going to divide that by 2, 4, 6, 8 minus 1, which is 7. So divide that by 7, and I get approximately 2.52. And then remember, I take the square root of that, which is approximately 1.59 inches. Alright? Alright, good. So exercise number 1, I'm going to assign that to you for homework because I'd like for you to practice these steps to let you do that. Alright? So let's go on with exercise 2 through 5. Our exploratory challenge. Alright. A group of people attended a talk at a conference. At the end of the talk, 10 of the attendees were given a questionnaire that consisted of 4 questions. The questions were optional, so it was possible that some attendees might answer none of the questions, while others might answer 1, 2, 3, or all 4 of the questions. So the possible number of questions answered are 0, 1, 2, 3, or 4. Suppose that the number of questions answered by each of the 10 people were as shown in the dot plot below. Use we don't have the calculator to find the mean and standard deviation of our data set, so we have to do it the old-fashioned way. Alright, so 1 plus 1 is 2, 2, 4, 6, 8, 3 and 3 is 6, and 4, so I have 20. So 20 divided by 10 is 2. So my mean is 2 questions. That means the typical person answers 2 questions. Now to find our standard deviation. So my deviation is 2. So 0 minus 2 is negative 2. 1 minus 2 is negative 1. Negative 1. I have 0, 0, 0, and 0. Now remember, I got to do each point. 3 minus 2 is 1, so I've got 2 of those, and 4 minus 2 is 2. Alright, so now I've got to square these. So I get 4, 1, 1, 0, 0, 0, 0, 1, 1, and 4. Alright, add them all together. So 4, 5, 6, 7, 8. 8 and 4 is 12. So 12 divided by, there were 10 numbers. So 10 minus 1 is 9. So we're going to do 12 divided by 9 is 1.33. And we're going to take the square root of 1.33, which is approximately 1.15. Alright, so our standard deviation is 1 and 1500 questions. Alright, suppose the dot plot looked like this. Use your calculator, which we don't have, but we do have a regular calculator to find the mean and the standard deviation. So let's find our mean. So I have 0 plus 0, 1 plus 1 is 2, 2, 4, 6, and 4 and 4 is 8, so I have 20. Divided by 10 is 2. So once again, my mean is 2 questions. Alright, now we're going to do this. So 0 minus 2 is negative 2. I have 2 of those. 1 minus 2 is negative 1. I have 2 of those. 2 minus 2 is 0, so I have 2 of those. 3 minus 2 is 1. I have 2 of those. And 4 minus 2 is 2. I have 2 of those. I have to square these, so I get 4, 4, 1, 1, 0, 0, 1, 1, 4, and 4. Let's add them. 8, 9, 10, 11, 12. 12 and 4 is 16. 16 and 4 is 20. So I have 20 divided by, excuse me, there are 10 numbers, so 10 minus 1 is 9. So 20 divided by 9 is approximately 2.22. And so the square root of 2.22 is approximately 1.49. So the standard deviation is 1.49 questions. Remember that the size of the standard deviation is related to the size of the deviation from the mean. Explain why the standard deviation of this distribution is greater than the standard deviation in exercise 2. So if you will look, the points in exercise 3 are, so here's my standard deviation, about right here. Here my standard deviation is about right here. My points are farther from the mean. Alright, so let's look at our mean here. If I look at my mean here, look, my points are kind of evenly distributed here. But if I look at my mean here, I'll have a lot of my points there. So my points are farther from the mean than the point in exercise 3 than the points in exercise 2. Okay. What I mean is I'm looking at my mean, and I've got more points farther away from my mean there than I do here, because most of my points are at my mean here in exercise 2. Excuse me. Pardon me. All right. So we have, this would be what we call a mound shape. Alright? And this would be what we call a uniform shape. And if you look at it, you can tell the difference. Mound shape, they kind of go to a peak and then back down. Uniform means they're all pretty much the same. So we have these two types of graphs. Alright, let's look. Suppose that all 10 people answered all 4 questions. Suppose that all 10 people answered all 4 questions on the questionnaire. What would the dot plot look like? Well, if all 10 people answered, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all of my dots would be there. So what would the mean of this be? Well, you should be able to do this without calculations. If they're all at 4, the mean is going to be 4. So what would the standard deviation be? Again, you don't have to do any calculations. Well, if they're all at 4 and the mean is 4, every time I subtract, I'm going to get 0. I square that, I get 0. I'm going to divide by everything. I'm going to divide 0 by something. My standard deviation is going to be 0. It will be 0 because all deviations from the mean are 0. There is no variability here. It's all in one spot. Continue to think about the situation previously described where the numbers of questions answered by each of 10 people recorded. Draw the dot plot of the distribution of possible data values that has the largest possible standard deviation, where all 10 people at the top, so they should do 10 dots. There were 10 people at the top, so there should be 10 dots on your dot plot. Use the scale given below. All right, so let's think about this. We want to know, where am I going to get the greatest standard deviation? The largest possible standard deviation. Well, if I have no deviation here, to get my largest standard deviation, that means I'm going to have 5 people answer 0 questions, and 5 people will answer all 4 questions. Why? The standard deviation of this distribution is larger than that of the one in exercise 4 because the deviation from the mean here are all greater than or equal to the deviation from the mean in exercise 4. All right? So these are going to be greater than or equal to the deviations from exercise 4. Alright guys, that's the end of the lesson. I hope you have a great spring break and really enjoy yourself.